Alright, we have my Rubidium frequency standard in lock. If it wasn't in lock, we'd be reading about 4.6 volts there, which means we're putting out a signal of 10 megahertz to within 5 times 10 to the minus 8th accuracy. And on the bench here I have a BK1805, and I've been calibrating it. Put it in a little calibration stand here, jury-rigged, and then I've been calibrating it, and we are exactly at 10 megahertz right now on the highest scale. So we're updating about every 10 seconds, and within the hertz we have 10 megahertz. I can kill the overhead lights, and that will help make it more visible. There we go. So I wanted to show you that we have the B&K in calibration with the Rubidium standard. So you're going to get a well-calibrated unit. It is functioning well. We'll run it through some tests with our PTS 500 and see how that goes. So I wanted to give you a quick look around on this this B&K 1805. This is the second unit that I've tried to refurbish here. I bought a lot of 11. It didn't come with power cords. The power cords were a particular type that aren't available anymore and would have run about $30 to $35 a piece. Was the cheapest I could find them, and there weren't very many of them. So I've installed a standard socket into the unit, which took some extensive work, but it's in there. I ground out the old socket and installed the new one, and provided a power cord. The stands on a number of these units were broken in transit, and I've had to repair the stands. I'll point that out. I used some super glue on the stands, and they've held for me now for the last couple of weeks, so I'm thinking they're going to work just fine. The readouts are very bright. I was able to calibrate the unit to the hertz using the Rubidium standard. Right now we're looking at 80 megahertz coming out of my PTS 500 synthesizer, RF synthesizer. The RF synthesizer has its own internal 10 megahertz oscillator, and although it was calibrated, the unit then multiplies frequencies all the way up to 520 megahertz. So that it's off a couple of hertz is still a remarkable event. I'm quite happy with it. But we are using the synthesizer to provide the frequencies because it gets us a very accurate frequency, and I'll be able to change it. So like right now we're looking at 80 megahertz. Earlier we saw the 10 megahertz calibration. I'm going to go ahead and turn this down. Here's 70. 60. 50. 40. 30. 20. We may be able to actually, well, if I do change the scale, it's going to change the time period that it takes to get the results. It takes 10 seconds on the most accurate setting. There we go, 19.9 0.99, so 19,999,993. So we're within 7 hertz out of the PTS and on the meter. Let's go to 10. We have to wait 10 seconds. We'll have to wait another 10. Let it update fully. Alright. There's 10 megahertz. Nine megahertz. I'm going to go back to the faster setting. We don't want to wait all day for this. 8. 7. 6. 5. 4. 3. 2. 1 megahertz. $900 kilohertz. 800. 700. 600. 500. 400. 300. I'm at the limit of my PTS, sorry. I'm not going to get better than 300 out of this. It really wasn't even meant to do that. I can switch this to my HP frequency synthesizer and we can pick up the low ranges. Take me a minute to do that. Alright, we're back to 300 kilohertz. There's 200. 100. Alright. 90. 80. 70. 60. 50. 40. 30, 20, 10. That's 10 kilohertz. 9 kilohertz. 8, 7, 6, 5, 4, 3, 2, 1. It's 1 kilohertz. Alright. There's 900 hertz. 800. 700. 600. 500, 400, 300, 200, 100. Alright, now I'm going to change this to the most sensitive scale. That'll raise it up by a power of 10, so give it a moment here. Unfortunately, it's going to take a lot longer to get our counts. Alright, there's 100 hertz. We're going to have to let it fully refresh. There's 90, 80. It's going to take 10 seconds. 70. If you catch it midway in its counting cycle, you're going to have to wait 2 cycles, so it could take 20 seconds. There's 70. I'm going to go to 50. We'll shortcut it. There's 50. We'll go to 30. There's 30. There's 10. I believe this is rated at 5 Hertz if memory serves me right. So I will take her down to 5. Alright, we should be on 5 Hertz. It's going to take it a moment to update. There we go. 5 Hertz. And just for kicks, let's try 2. It's really not rated for 2, but there it is. And 1. Okay. So you can actually read frequency all the way down to a hertz. Interesting. The better way would be to read the period. And you would read the period in microseconds, and it would start, it would count the number of microseconds between each cycle. Okay, it's telling me that I have 200,000 microseconds. So 200,000 microseconds is 0.2 seconds. And 1 over 0.2 is 5. So that is reading 5 Hertz right now and resolving it in microseconds. So you got a lot more accuracy here. You don't just have 1 digit, many digits. The period's working good. Now there's a totalize function on here too, and it just counts pulses coming in. And you can, if you had an application where you wanted to count number of pulses that represented turns on an encoder or something like that, you could do it. So that's good to know. And we have a reset if we wanted to start over again. We have a hold if we want to hold the data. You've got a filter on here if you want to filter out some noise. And then you have a ×1 ×10 attenuator. It'll handle 200 volts peak max. It goes from 5 Hertz to 80 megahertz. In fact, it shows me that right here. I missed it earlier. It's a 1 megohm input. The stand pulls out and rotates. You can get it out of the way. You can set it on a shelf where you can use the stand. And all in all, an excellent unit. There we go. 1.05 megahertz out of my generator right now. So thank you for watching. I will provide along with this an excellent manual. Safety, introduction, specification, controls, operating instructions, circuit description, maintenance and calibration, circuit boards and maps, parts lists, we have the schematic drawings. I have them in both 8.5 and 11, and I also have them in 11 by 17. Much easier to read. And guess along with that, I'm going to give you a set of leads. It's a brand new set of leads. Coax with the alligator clip adapters. That'll give you the most adaptable if you're working with circuitry. Probably the majority of the time you'll work with the coax end to end, and that'll be out of your own supply. But I will give you a set of leads. So there you have it. How can you go wrong, huh? Everything all in one. Thank you for watching. Happy bidding.